Let's discuss about mesh analysis. In this technique of circuit analysis, we have to write KVL equations for every possible mesh in an electrical network. In these equations, there may be some known terms and there may be some unknown terms. By solving these equations, we can derive the unknown terms. Mesh analysis is one of the simplest and easiest techniques of solving network. According to KVL, the arithmetic sum of total voltage gains and drops in a closed loop of a circuit is 0. If we go through one example, it may be clearer to you. Let's consider a network having a voltage source. Here it is battery of 6 volt across which two series combination of resistors R1, R2 and R3, R4 are connected as shown. Now we will discuss the mesh technique in step-by-step manner for the example given in the figure for better understanding the method. Step 1. As we have explained earlier that every complete network is a mesh network. So for mesh analysis, first we have to identify the possible meshes in that network. There are two meshes. First one is formed by resistors R1, R2, voltage source V, and say it is mesh 1. Second one is formed by voltage source V, resistors R3 and R4, and say it is mesh 2. Step 2. Now choose two mesh currents, one for mesh 1 and say it is I1, and other is for mesh 2 and say it is I2. The direction of these two currents may be taken as arbitrary, but it is a better convention to choose both currents in the same direction. Here we have chosen both currents I1 and I2 in clockwise direction. Step 3. Next step is to identify the polarities of each element connected in the mesh. The polarities of voltage drops must be positive at upstream end and negative at downstream end of a resistor. Generally, we mark plus at terminal where current enters in the resistor. The battery polarity should be as orientations given in the diagram. Step 4. Now for mesh analysis, we will apply KVL and generate voltage equation for each mesh in that mesh network. Here the mesh equations are minus I1 into R1 minus I1 into R2 minus V equal to 0 for mesh 1 and say it is equation 1. Plus V minus I2 into R3 minus I2 into R4 equal to 0 for mesh 2 and say it is equation 2. In the figure, R1 equals 4 ohms, R2 equals 2 ohms, R3 equals 1 ohm, and R4 equals 5 ohms, and V equals 6 volts. After putting the values of R1, R2, R3, R4, and V in the equations 1 and 2, we get 4 into I1 plus 2 into I1 plus 6 equal to 0, or 6 into I1 plus 6 equal to 0, or I1 equal to minus 1A. 6 minus I2 minus 5 into I2 equal to 0, or 6 into I2 equal to 6, or I2 equal to 1A. The value of current I1 becomes negative, which implies that the actual direction of current in the circuit was opposite of our assumption of mesh current for mesh 1. As the value of current I2 is positive, the direction of actual current and assumed mesh current matches. Thank you.